Hey everyone, welcome back to D-Tech Automation. In this video, we're going to decode the model codes of Balmer and Endress-Hauser pressure transmitters and understand every small but important parameter you see on a transmitter datasheet, like process connection, electrical connection, housing, IP rating, certifications, accuracy, diaphragm, filling fluid, turndown ratio, and much more. And stay with me till the end of the video, because I'll also show you the real process connections and electrical connections used in actual transmitters, so you can see exactly how they look in real life. Let's start with the first parameter, process connection. In any field instrument, whether it's a pressure transmitter, level transmitter, or temperature sensor, the process connection is the interface between the instrument and the process line. It's the point where the sensor meets the medium, like liquid, gas, or steam. There are many types of process connections depending on the application. A. Threaded connections, most common for compact transmitters and general applications. Threads can be parallel, G, or tapered, NPT type. Common standards: half-inch NPT, male-female, American National Pipe Thread tapered. Half-inch or 1/4 1 BSPP, British Standard Parallel Pipe. M20 x 1.5, metric thread. This connection are mainly used in applications like gas lines, water service, utility lines, low viscosity fluids, and generally made of SS316, brass, Monel, Hastelloy, depending on process media. Then comes B. Flanged connections, which are used in large diameter pipelines, high pressure or corrosive service. Bolted to process nozzle using a gasket for sealing. Standards connections are ANSI, SAME B16.5, DIN EN 1092-1, JIS 10K 20K. Common sizes starting from half-inch to 2-inch, etc. These connections are mainly used in steam lines, reactors, high-pressure systems. Third one is C. Hygienic. Sanitary connections, designed for clean-in-place, CIP, and sterilize-in-place, SIP systems. Smooth surfaces with no dead zones, such as tri-clamp, tri-clover, DIN 1151, SMS 1145, Vericent, APV, NUM. These connections are used in food, dairy, beverage, pharma, and are made up of polished SS316L with PTFE or EPDM seals. Manifold direct mount. This type of connection are used in differential pressure, DP transmitters, mounted via 3-valve or 5-valve manifolds. Provides isolation, equalization, and calibration ports. Mainly used in an application like level, flow, and differential pressure measurement. Now comes the second parameter, that is electrical connection. It's the point where you connect your signal cable or power cable to the transmitter. /P. There are mainly 5 types of electrical connections used in process automations. A. Cable gland entry, most common for industrial transmitters, and provides strain relief. Sizes M20 x 1.5, half-inch NPT, PG 13.5. These are made of nickel-plated brass or stainless steel. It is commonly used in field wiring with armored or unarmored cables. B. Additions to the product. Ending and offering a positive and beneficial outcome. Addition, always. Conduit entry. Used in hazardous areas to route cables through flame-proof conduits. Threads, half-inch NPT or M20. Often includes a conduit seal fitting to prevent flame propagation. Used for flame-proof or explosion-proof EXD transmitters. C. Plug-in connectors. Compact form for quick installation. Standards: M12, 4-pin or 5-pin. DIN 43650 for pressure switches. Parting connectors. Used for compact transmitters, test benches, or OEM machines. Terminal block access. Parentheses, found inside transmitter housing. Provides screw terminals for to power supply of 24-volt DC. Signal, 4 to 20 millibits. To communication, HART Fieldbus. Often labeled as positive or negative. DIS, Fieldbus ports. Digital connections for smart communication. Profibus PA. Foundation Fieldbus. Modbus RTU TCP. Used for smart plant integration and diagnostics. 4. IP rating, 3 to 345. IP equals ingress protection, defined under IEC 60529. It describes the level of protection the enclosure provides against intrusion from solids, dust, and liquids. Water. Structure of IP code. IPXY. X. Protection against solids, 0 to 6. Y. Protection against liquids, 0 to 9. IT rating table. Let's understand what IP codes actually mean. IP stands for ingress protection, and it tells us how well an electrical device is protected against dust and water. Let's go through some common IP ratings one by one. IP00. No protection at all. The equipment is not protected from dust or water. IP54. Dust protected and resistant to splashing water. Common for indoor applications where there's light dust or moisture. IP65. Fully dust-tight and protected against water jets. This is suitable for outdoor installations. IP66. Again, dust-tight but can also handle powerful water jets. Perfect for harsh outdoor environments. IP67. Completely dust-tight and can even handle temporary immersion in water, like accidental submersion for a few minutes. IP68 offers complete dust protection and can operate even under continuous immersion in water. These are truly waterproof devices. IP69K, the highest level of protection. Dust-tight and can withstand high-pressure, high-temperature water jets, often used in food, beverage, and pharmaceutical industries, where frequent washdowns are required. So, the higher the IP number, the better the protection against dust and water. Always choose the right IP rating depending on your application environment. First, why it's used. It prevents dust, moisture, and chemical ingress that can damage electronics. Ensures reliability and safety in harsh environments. IP67 or IP68 transmitters can handle outdoor or flooded conditions. Fifth parameter is certification. Certifications define whether a transmitter is safe to use in hazardous or specific environments, like explosive gas zones, mines, or marine applications. Each certificate follows a regional standard that ensures the device won't ignite, corrode, or malfunction under harsh conditions. Main certification categories. ATEX stands for Atmospheres Explosible, governed by the EU Directive 2014-34. Classify equipment into zones and categories. B. IECEx certification. IECEx is similar to ATEX, but it is globally accepted according to the IEC 6079 standards. A typical marking looks like EXIA IIC T6. Here means intrinsically safe. IIC indicates the gas group. It's the temperature class. And GA shows that the device is suitable for Zone 0 applications. FM and CSA, used mainly in North America. FM stands for Factory Mutual in the USA, and CSA refers to the Canadian Standards Association. These certifications follow the Class and Division system. Class 1 for gas atmospheres. Class 2 for dust. Division 1 means continuous presence of the hazard, and Division 2 means it is present only occasionally. An example marking is Class 1, Division 1, Groups B, C, D, T6. These certifications ensure that the equipment meets the safety requirements of each local authority. Now let's look at two more important certifications used in the industry. Marine and shipbuilding approvals. These certifications are required for offshore platforms, marine vessels, and naval installations. Well-known certifying agencies include DNVGL, Lloyd's Register, ABS, Bureau Veritas, and RENA. Equipment approved for marine use is tested for vibration, salt spray corrosion, humidity, and EMC resistance. This ensures that instruments can survive extremely harsh ocean environments. F. Functional Safety Certification, SIL. SIL stands for Safety Integrity Level, defined in IEC 6158 and IEC 615011. This certification is used for safety instrumented systems, where equipment must perform reliably during a critical safety event. Transmitters that are SIL-2 or SIL-3 certified ensure that they can provide dependable action, especially for emergency shutdowns, interlocks, and protection loops. These certifications ensure that equipment not only meets explosion protection standards, but also performs reliably in marine and safety-critical environments. Now let's talk about the output, the electrical signal that your transmitter sends to the control system. This output defines how the instrument communicates with the PLC, DCS, or controller. Analog output, 4 to 20 mA. The most common output in the industry is the 4 to 20 mA current loop. It's highly reliable, immune to noise, and can travel long distances, even up to 1 kilometer. Many transmitters also superimpose HART communication on this same loop. The advantages are simple. It's reliable, easy to maintain, and gives a linear response, where 4 mA represents 0% and 20 mA represents 100% of the measurement. Voltage output, 0 to 10 volts or 1 to 5 volts. Voltage outputs are usually used in laboratories or low-noise environments. They're more sensitive to signal drop over long distances, so they're mostly found in OEM equipment or HVAC control systems. Digital communication. Next is digital communication. HART is a hybrid system. It carries a standard 4 to 20 mA output and a digital signal on the same wires. This allows you to perform remote calibration, configuration, and diagnostics. Fully digital Fieldbus systems include Profibus PA, Foundation Fieldbus, and Modbus RTU or Modbus TCP. These systems allow multiple transmitters to operate on a single network, ideal for smart plants, DCS, and modern automation setups. Switch or relay output. Some instruments provide a simple on-off output. This is used for pressure switches or level switches. For example, output 1 can trigger a high-pressure trip, and output 2 can trigger a low-pressure alarm. Now, let's talk about accuracy. Accuracy defines how close your transmitter's reading is to the true value. It includes 4 key components. 1. Reference accuracy. Under controlled conditions. 2. Temperature effect. How readings drift due to temperature changes. 3. static pressure effect, especially in DP transmitters. 4. Long-term stability, how much the sensor drifts over months. Premium models offer 0.04%, such as the PMC-71 or Rosemount 3551S. Ultra-high accuracy units can reach 0.025%, like the ABB-266 series. Why does accuracy matter? Because higher accuracy means better control, especially in custody transfer, batching, and DP flow measurement. Turndown ratio. Turndown ratio shows how flexible your transmitter is. It's the maximum calibrated span divided by the minimum calibrated span. For example, if the sensor range is 0 to 100 bar and accuracy is guaranteed down to 10 bar span, the turndown is 10 to 1. Standard transmitters offer about 10 to 1. Smart transmitters go to 20 to 1. High-end models like E+H and Rosemount can reach 100 to 1. Diaphragm and filling fluid. The diaphragm is the first surface that touches the process, and the filling fluid transmits pressure to the sensing cell. Different diaphragm materials serve different applications. Stainless steel 316L for general-purpose fluids. Hastelloy C276 for corrosive chemicals. Monel for hydrofluoric acid and caustics. Tantalum, excellent for strong acids, especially HCl. Gold-plated stainless steel for very low pressure or vacuum. Ceramic, ideal for slurry and abrasive media. Filling fluids. Silicone oil, standard, from -40 degrees C to +200 degrees C. Halocarbon oil, safe for oxygen or chlorine service. Fluorinated oil, high temperature, chemically inert. Glycerin, food-grade oil, for pharma and food applications. Now the last parameter is zero and span adjustment. Zero defines your starting point. Span defines your full-scale endpoint. You can adjust them using /filter or HART communicator software like AMS, PDM, FieldCare. Remote or Smart Zero for inaccessible installations. A standard calibration procedure includes applying 0% and 100% pressure, adjusting zero and span, and verifying linearity at 25%, 50%, 75%, and 100%. Period. Hey everyone. All right. With the theory and working principle fully explained, it's time to see how things look in the field. Let's move ahead and take a real-world demonstration of each process connection, electrical connection, and flange connection. This will help you relate the concept with actual instruments. Threaded process connections. Let's begin with the threaded process connections. This is a 1/2-inch NPT connection, a tapered American standard thread. It is widely used in gas lines, utility lines, and general industrial applications. Next, this is a 1/2-inch BSPP connection, British Standard Parallel Pipe. It has a straight thread and is commonly used in Europe and Asia. And stay, here we have a 1/4-inch NPT connection, a smaller tapered thread used for compact transmitters and small instrument lines. This is the 1/4-inch BSPP connection, a parallel small bore thread used in low pressure or compact instrument applications. Similarities. Flanged connections. Now let's look at flanged connections. This is an ANSI flange connection used in high-pressure steam and heavy-duty industrial services. And here is the ASME flange. It provides strong sealing using bolts and gaskets and is ideal for reactors, steam lines, and high-temperature pipelines. 3. Hygienic sanitary connections. Next, we move to hygienic or sanitary process connections, used in food, dairy, beverage, and pharmaceutical applications. This is the tri-clamp or tri-clover connection. Smooth, easy to clean, and ideal for CIP and SIP environments. This one is the SMS 1145 sanitary thread, commonly used in dairy and pharma processes for leak-free hygienic operation. And here I'm showing you a Balmer pressure gauge with a sanitary connection. This type of polished hygienic fitting is designed specifically to avoid contamination and ensure clean, safe measurement in food and pharma applications. Welcome to the end. Section 31. Hygienic and sanitary connections. Airy, manifold, direct mount. The manifold or direct mount interface used for differential pressure transmitters. It is designed to connect with 3-valve or 5-valve manifolds, which provide isolation, equalization, venting, and safe calibration for DP transmitters in flow and level measurement applications. Now, let's look at the electrical connections. The first one is the M12 4-pin connector. This type of cable is commonly used in small level measurement instruments and level switches. If you look closely at the cable, you'll find a small pin indication marking inside the connector. This marking helps you identify each pin clearly, so you can connect it correctly to the instrument without any confusion. Next, we have the DIN 43650 connector. This type of connection is widely used in instruments like pressure switches and pressure transmitters. The wiring here is quite simple. You just need to connect the strong, positive and negative terminals to the correct points on the transmitter. Once the terminals are fixed in place, you can assemble the connector back together. It's a very straightforward and easy-to-wire connection, commonly used in industrial applications. These are the two basic electrical connections: the M12 4-pin connector and the DIN 43650 connector. If you found this video helpful, don't forget to like, share, and subscribe to D-Tech Automation. All right. With the theory and working principle fully explained,